Okay, gang, remember on 99, I'm looking for 3 parts, all right? So you're not going to answer the way the book asks the question. You're going to answer it the way we're doing in lecture. So the first part that you want to do is you want to say that f of x is continuous on the interval because that is a prerequisite. That has to be true to be able to use the intermediate value theorem. All right, so this is a parabola. Parabola is always continuous. But if the function is not continuous on the selected segment of the domain, you actually can't use the theorem. So it's important that it passes the prereq. All right, so I'll break it down in 3 parts, but you could just write it as a nice paragraph on the test, or you could break it down in 3 parts. So the first part you want to acknowledge is you want to say that f of x is continuous on the interval. So this parabola is continuous from 0 to 5. Right, this is a domain restriction, it's not a coordinate. All right, the second thing you need to show me is that you're solving for the y values that correspond to these x values. So you're going to plug in 0 into the function. So you're plugging it into the function. So f of 0 is -1. That is the output or the height at 0. You plug 5 into the function. All right, so that's going to give us 29. So what's basically happening is that the parabola is going, because it's considered a continuous function, it's going to cover all the heights between -1 and 29 because it's continuous. Okay, it's going to cover all the, let me say that a little better. It's going to cover all the y values in between -1 and 29 because we know it's continuous because of what we said in the first part. All right. Now the third part, you have to make sure that you invoke the intermediate value theorem. If you don't say that anywhere in part 3, I'll take off points because what I'm looking for is for you to use the theorem. Okay, so please make sure that you actually use the theorem. All right, so what we're trying to say here in the problem is it's saying confirm to me that you have an 11. And I can confirm that because if I'm going from -1 to 29 and I have all the values in between, then I must have an 11. I must pass through an 11. I have to because I'm not missing any of the points. All right, so here we go. So since the function is below 11 and the function is above 11, we must at some point pass through 11. So since we're below 11 and the function, oh, let me say this a little better. All right, since f of 0 is below 11 and since f of 5 is above 11, the intermediate value theorem guarantees that there is at least one value of C such that f of C equals 11. All right, so what I'm looking for is that however you write this, you're going to say that the intermediate value theorem is what's guaranteeing 11. All right, that's what I'm looking for, that you're going to invoke this because this is guaranteeing that we have the 11. Now, if you want to answer the question that the book is asking, well, what is that C value? So how you would find that is you would set the function equal to what you want it to output, which is 11. Then I'm going to move the 11 this way, so I have to subtract it. And then I would factor it. Okay, but I'm asking for this on the test, okay? Not what the book is asking. I'm just showing you in case you're interested. All right, so that has to be a +4 and a -3, so therefore x is going to be 3 and -4, but I have to stay in between here, so there's no -4 in between there. So they're asking for x is 3, if you're trying to solve that. All right, gang, that's it on this one. Catch you. Bye-bye.